Hi, this is David from Arzaman Engineering, and in this video I'm very happy and proud to introduce you the first vertical and dedicated application that runs on the SmartPID platform. The application is completely dedicated to home brewing process automation, and we have called Smart Homebrewing app. Is very powerful and flexible application that allow you to manage all the process in all the steps, from the machine to the step mesh to the boiling, up addition, whirlpool, and cooling. It's very flexible and you can adapt to any setup with the one single vessel, brew in a bag system like, or with two vessels, and you can control also your sparge water. Of course, you have a lot of parameter to tune your process, and moreover you can manage all your recipe, adding your mesh profile, boiling profile, and up addition profile. This application has been developed on top of the standard simple application, so you can benefit all the standard features, so login, Wi-Fi connection, and so on. Hope you find interesting. I leave you to check out all the features on the website, and in this video we try to show you how to configure all the parameters, and we run a complete simulation of a brew day. Let's see now in practice how home brewing SmartPID application works in practice. In order to do this, we are going to use the SmartPID simulator. SmartPID simulator is a software in Windows environment, so can run easily on your desktop PC that emulate and simulate 100% what happens on the physical board. What you see here is exactly in terms of user experience, but also from process point of view, what runs on the SmartPID board. So let's start from the, as usual, top level menu. There's no so much difference from this menu and the standard basic application menu. What is new basically is the recipe management menu. We'll see later. Under this menu, you can define, configure your recipe for brewing. Let's go to the configuration first and see what are the specific parameters that we have added for the vertical homebrewing application. Let's start from the hardware setup first. In the hardware configuration, we have removed everything related to cooling, everything that is not strictly needed for a homebrewing application. Here you can see that you can choose the heating mode, either electric with PID control or gas-fired through the on-off control. In this menu, it's very important because you define what is your setup. Just one single vessel, for example, for a brewing a bag application, or two vessels, so you can control either mesh tun or and the sparge water vessel or hot liquor tank. In this case, just for simplicity, we choose mesh only. Since we have choose just the mesh, now we can assign the hardware resources, the output, to the correct process and channel. The mesh channel, the mesh process has been assigned to the solid state relay. Let's suppose that we have to drive a heavy load, so it's better to use a solid state relay. The HLT heating is off since we have just meshing. And then we're supposed to have a recirculating pump, and we assign this to the relay number 2, but we can also use maybe a 12 volt DC pump and drive directly from one of the two output. Last, we define the mesh probe, and we assign this to a specific probe. We can also choose, of course, the standard NTC sensor temperature. That's all for the hardware setting, so quite easy. Let's see now unit parameter, what is specific for this application. Apart from the standard parameter, the most relevant one is this, the mesh probe position. You can put your temperature probe either inside the mesh tan or outside. Typically in a BIAB system, on a recirculating system, you can also decide to have this in the recirculating circuit, and this will affect greatly the pump behavior. We add also this parameter just to prevent to damage the pump. We put a threshold maximum temperature of your pump where the process stop to use the pump. That's all. Now the process parameters that are quite a lot specific for this type of process. The first set of parameters are typically used by the manual mode, so you can skip. These are default temperature, time, and etc. Then you have all the classical constant for the PID algorithm or the hysteresis in second for the on-off algorithm. And these are different, of course, for the mesh or the HLT process. Then we have a sample time PWM period, exactly like basic application, frequency of the sampling of temperature, and frequency for the PWM. Here starts the specific parameter. Boiling PWM point and percentage indicates what is the temperature you consider for the boiling and what is the power that you would like to apply when you reach the boiling point. Pump cycle, pump rest define just a on-off period for the pump during the meshing. Then we have a set of flags: mesh in pump, step mesh pump, mesh out, and boil pump that defines if you want to use the pump in this step. Let's suppose that you don't want to use the pump during the boiling, just simply flag no. In this case, we keep all the flag yes. We have another set of flags that define the user behavior and user interaction. The process prompt you to do some action in some specific point. You can decide or to skip or to do a manual confirmation. If you set no, the process goes straight to the next step without any interaction. Then we have the whirlpool setting. We can decide to do hot whirlpool or cold whirlpool. Let's choose hot whirlpool. Whirlpool time, for simplicity, just 1 minute. And then the cooling temperature. So now we have configured your hardware, your physical parameter of your hardware, and all the process setup. What you need more, of course, is a recipe to run the process. Let's go to the specific menu. Here you enter the recipe management section where you can input a new recipe, edit the existing one, delete, clone, do whatever you want, and you can store in memory up to 10 recipes. Let's have a look how a recipe is organized. We have just one sample recipe. Recipes is split in two: meshing profile and boil and top profile. Under the meshing section, it's quite simple. You have to define mesh in temperature, mesh out, and then all the step mesh in between. The step mesh are defined by two values: temperature and time. If you set time equals 0, this means that this step is simply skipped. Here we have machine 60 degree. Of course, we skip all the intermediate steps. So phytase, glucanase 0, protease is 0. We decide also to skip beta amylase, alpha amylase 2. It's just a simple recipe with one single step just for simplicity. This is mandatory, at least one step for starch conversion, and we define 73 degree for this step, and here you can change your time. Mesh out temperature, that is mandatory, and mesh out time, just 1 minute also for this. That's all for the mesh profile. Boiled up is even simpler, just the boil time. We put for simulation 3 minutes, and how many hops addition we have. For the hop addition time, you just put the remaining time from the end, so 2 hops, one at 2 minutes from the end and one at 1 minute from the end. So recipe is done, is already saved, so I will not do confirm. So go back to the main menu and see how the process works. Run mode, 2 options. Manual mode, quite simple, we skip this for the video. Just enter a manual mode where you can set up your set point and manage the heating of the mesh tun and the sparge water, nothing more, and then you can of course activate manually the pump or the stirrer. Let's go to auto mode, more interesting. At this point the process asks you to load a recipe. We loaded the demo recipe we have already defined, and then you are prompted to decide if you want a delay start. Maybe you want to prepare in advance your brew day and start with the sparge and the machine water already in temperature, or do an immediate start. Here is the first prompt, first question. The process asks you if you have added your water, of course, otherwise you can damage your equipment. Let's suppose yes, we confirm. Here we are. Here is the main screen. Now the temperature you see is 20 degree, and we have defined the recipe, remember 60 degree for the machine time. You see here blinking the relay number 2, where the pump is connected, just an on-off cycle to avoid to have air or bubble inside. Then the pump is on, since the flag was machine pump yes. The output of the heating element, of course, is on, since temperature is 60 degree, we have a current temperature of 20, and so 100% power PID calculates the output and is correct to have 100% output. Let's simulate the increase of temperature. We are heating the wort up to 60 degree. Let's see, 47, 49, 64. Okay, we reached the machine temperature, and now the system asks go in a sort of standby mode. It keeps the temperature, switch off the pump, and you can add your grains to the water. So once you have completed to add your malt, you can confirm, and the first step starts. In this case, we have defined alpha amylase 2 at 73 degree. Again, the pump is on, and of course here if you have longer time, you see the pump on and off according to your pump cycle timing, and the output again is on because we are far from the setting point threshold. Let's suppose that temperature increase again and reach the target. to simulate the first step. Okay, we exceed a little bit, never mind. So, beta analysis temperatures has been reached and a counter starts. We have defined 1 minute for this step, and you see here a countdown is going. Now the PID realized that we have too high temperature and switch off the output. Let's try to reduce a little bit and start again, I think, to converge. While the time is running, just to show you the graphical part. Here you see we have done first ramp, then this was the machine, then we increased the temperature, and now we are here with this set point and the current temperature just a little bit higher. In the meanwhile, the step has been completed, and so this is the unique step. We had the system ask us to do the iodine test to verify the starch conversion. In this case, again, for safety reason, we switch off the pump. We answer yes. And then last step, mandatory, of course, the mesh out 77 degree. We try to increase again temperature. SSR in the meanwhile start again working, you see. The PID is try to converge to 77. We do through the simulator. Okay, got it. Mesh out reached. 1 minute more. The pump again is on since we decide this during the setup phase. And you see here the output. Let's see again the graph part. Here you have your nice graph. Of course, all these data are logged locally, and you can export via USB and CSV file, or can be pushed through the Wi-Fi connection. Now, of course, the emulator is not possible, and you can analyze and log and view remotely on your smartphone or web. We are reaching the end of the mesh out. Mesh out completed. And now the process I expect ask if we have extracted the malt. Pump off, we keep the temperature at the same level, and we have to remove, of course, our grain to start the boiling. We answer yes, and now straight to the boil phase. In this phase, you just increase temperature as much as possible, as fast as possible, so you don't need a PID control, just go full throttle, and as you see here the SSR is on and 100% power. Let's increase the power and have a look what happens at 80 degree. Here it is, the relay of the pump switched off since we set this threshold as maximum. Go to the boiling point. Okay, here we are. Boil temperature reached, fine. Here you see 85% power. That is what we have defined in the setup in the process parameter. At this point, you have stable boiling. In order to avoid overboil, we define 85, but you can change with up and down buttons. You see, you don't modify anymore the temperature, but just the power. This is, of course, valid for an electric setup. You can control very easily the percentage of power applied to your heating element. If you set, for example, you set 50%, you see the output is 50% of the time on and 50% of the PWM time off. That's very cool. In the meanwhile, the boiling time is running. First stop addition, you remember 2 minutes. We are still other 2 minutes to wait. So we can increase a little bit the power just to show you how it works. Just a few words while we are waiting the expiration of the boil timer, how it works if you have two vessels, so you control two process, two channels. You just have another screen like this where you can control the temperature of your sparge water. Of course, in this case, you don't have any step mesh. You see in the meanwhile the second up addition alerts. Uh, as I was saying, on the sparge water, on the HLT, you don't have any process control, just simple temperature control, and you can modify just the temperature set point. We are closing the boiling phase. A few seconds more. And next step will be whirlpool. We have defined hot whirlpool. We can choose as well the cold whirlpool. Here it is, boil completed, and whirlpool starts. The power has completely switched off, of course, we have completed the boiling, and since we assume to do whirlpool by pump, the pump is on. 1 minute whirlpool. Of course, you can connect to this relay also a motor steerer, and there's no strict need to use a pump for recirculating. You can also use a motor. That's a feature you can use. Last second for the whirlpool, and you see here the temperature is 25. That is what we have defined for cooling. Now you can start your cooling process with the cooling method you prefer. Here you just control the temperature, and you can even activate the pump. Here I cannot do because I have to do a double press, but you can also activate during this phase the pump to keep the wort uniform. So let's go down to the cooling temperature. So you can monitor your cooling temperature. Okay, done. That's all. Since we have completed all the process, we go back to the main menu. Hope you like this video, a little bit long, but so you have all the information how to configure the homebrewing SmartPID application, what are the vertical and specific parameter, how the recipe management works, and especially we have simulated a complete brew day from the machine to the whirlpool and cooling end to end. Hope you like this video, subscribe the YouTube channel, and of course stay tuned on all the other channels, the website, newsletter, and Facebook and Twitter. Thank you for watching.